Guys, how are you? Today we are going to start talking about turbines. Databook datasheet de Turbinas. How do people start turbine calculations? Like people, can increase the efficiency of machines and especially isentropic efficiency. But first of all, I want to begin talking about steam levels in an industrial plant, and also using the Maillé diagram. So we're going to use a Maillé diagram model, know the different levels of steam. And then we will also understand the difference between a turbine and a valve. Pressure reducer. What is the basic difference, and also from the point of view of knowledge of how the enthalpy of turbine work delivery works. The valve that does not deliver work, but still generates steam. We're going to start demystifying all of that now, okay? So, first of all, let's start talking about the vapor levels of an industry so that it can produce what it needs. Produce, whether from a petrochemical or from paper and cellulose. Be it one type of industry or another, a sugar and alcohol industry, in short, any industry that uses steam, it normally divides the steam in pressure levels, usually starting at a high pressure level, which is the level where you will generate steam naturally through a boiler. If you are going to have a boiler producing steam under high pressure. And these levels, the steam will be used initially at high pressure to generate, for example, electrical energy or work on some machine. A compressor, a pump are machines that would be large, and that, from an energy point of view, is worth it. You use it in a steam system instead of an electric motor, for example, because the departure of this machine. It's a somewhat complicated thing, given the great power required by a compressor or a pump. This makes it necessary to use a turbine and an electric generator. Also in the sugar and alcohol plant, the paper mills, they have an excess energy, so nothing more interesting to generate electricity with this excess energy. And it will come from burning bagasse, for example, selling black liquor, anyway, of a series of products that can be fuels that can be transformed into energy. Okay, so there you will have it too. In the case of industry, a second level, a high level of pressure, now an average pressure level. What is this average pressure level? It is usually the level of steam consumption in industrial processes. For example, a distillation column, heating of reboilers. In the distillation column you can have column rectification with steam. Ultimately, you will have a series of processes that use steam at medium pressure, including small turbine engines, which are used for the movement of pumps. You make the electric steam pair. If you have a thermoelectric balance in your company, your plant of a motor, it can be electric and it's redundant a steam turbine. So you make this pair to counterbalance and make the balance the electric term, okay? So what can we see? Initially is that, in the case of the high pressure system, we use a turbine to produce medium pressure steam. So we use a counter pressure turbine, or a total extraction turbine. So we can produce medium pressure steam. We will have some in the medium pressure system, some other steam generators. You might have, for example, a steam generator that it uses the heat from its process to generate steam. So this is common in industrial plants. But we have it here, in this one. These two levels of pressure, both high and medium, it's an interesting fact. Let's think about the following. Let's imagine that this turbine needs to be stopped for maintenance. If I stop it for maintenance, I will stop consuming high pressure steam. What if I stop consuming high pressure steam? I'm going to have a vapor deficit in this header, in the medium pressure header. So to supply this lack, a pressure reducing valve is installed in the system. So this pressure reducing valve, she will see the pressure on the average header and will open as we run out of steam here. In other words, the pressure tends to drop, it opens to be able to feed the media header, then it reduces the pressure. It has a pressure drop here at the valve, a pressure drop where it can maintain a pressure level lower than that in relation to the high pressure level. So the reducing valve is a strategy to supply steam when the turbine is inoperative. Or let's give an example too. For example, if you have a generator here where you does not need to generate so much electrical energy, what will happen here in this case? The steam consumption will decrease. The consumption of steam passing through the turbine decreases because the energy demand by electricity drops, and necessarily the steam flow will decrease here in the average header, forcing the reducing valve to admit more steam to the media header in the same way. Finally, we have a pressure header called low pressure, usually the low pressure header. It is used exclusively for heating, so process heating again, which distillation tower reboilers use low pressure precisely because the enthalpy jump between vapor and liquid is very large. So guys, there is a very large energy transition from vapor to liquid. And this is used in the reboilers so we can absorb as much heat as possible. So this low pressure system is extremely important to be able to make this transition from vapor to liquid. And that's why it's used a lot in pipe heating. We call it steam tracing. These are traces of steam, they are the piping. It is covered with an outer tube. The piping inside a process, it is coated with the external tube to keep the heat in this pipe. Then it keeps the pipe heating using low pressure. Tank heating too, that's important. For example, viscous products or fermentation vats. It uses steam to heat up and start heating the dough in the process. Okay, so we have 3 levels of steam. We can have more steam levels. This depends a lot on the process configuration. But here I'm basically talking about 3 levels, which are the most common. There could be 2, but these are the 3 most common levels that we see in the processes. And now we will begin to understand the operation between the turbine and the pressure reducing valve. Why do I have a pressure reducing valve? And is it worth keeping the pressure reducing valve? Let's get this straight. Now,